Hello everyone, welcome back. In today's video, we will explore the seamless integration of Amazon Bedrock API with a Spring Boot application. This powerful combination empowers developers to leverage advanced AI capabilities within the robust Spring framework. To get started, open VS Code or your favorite editor, create a Java project, choose Spring Boot, select Maven project, select the version, language as Java, group ID we will change it to Slight Insight. You can use any name that you like. Artifact ID would be assist, a short form of assistant. Package type would be jar version 17 and we will add web dependencies. That's all for now. Save the project in your local drive and open the project. Next, open AWS Management Console and switch to Amazon Bedrock. Click on Get Started. From the left navigation menu, select Model Access. Request for all the foundational model access so that we can invoke them from our Spring Boot application. Now switch back to VS Code and open pom.xml to add necessary dependencies required for our project. To speed things up, we'll follow the instructions from my blog post, copy the dependency management and add to your pom.xml file. Similarly, copy the Bedrock dependency and Bedrock runtime dependencies and add to your file. Next, open application.properties file and add AWS configuration properties which will be used to establish connection with the AWS. So we would require AWS access key, AWS secret key, and the AWS region. Next, create AWS config.java file under config package. In this class, we will add the code for establishing connection with AWS. First, copy the code for bringing in the required values from application.properties file. Next, we will add the method for AWS credential provider, which takes secret key and access key as the parameters to establish the connection with AWS and returns an authorized token, which then will be used by the bean for creating a AWS client. In this case, we are going to create a bean for Bedrock runtime client, which accepts region and AWS credential providers as the parameter and creates an instance of Bedrock client for us. Now let's create a model under package model with name prom.java. This will be used for passing as a request body for our REST API endpoint. In this class, we will add a string variable for asking question and we will add the getters and setters. Also add the no argument constructor, then save the file. It's time we create a service class under package service with name assistant service.java. The first step is to create a variable for foundational model. In this example, we are going to use Anthropic Claude V2 foundational model. Let's add the Bedrock client instance, then add a function ask assistant, which accepts prompt as the input parameter. The prompt has to be reformatted, starting with human and ending with assistant. This is the acceptable format for Claude. Then we are invoking synchronous response function, which takes this formatted prompt as the input. Now let's add the code for the synchronous response function. In this function, the very first step is to create a payload. In the payload, we are passing the modified prompt as one of the parameter. Then we are telling the number of tokens that we would require as a response. Followed by we are setting the temperature. Lower the value, the more relevant response we get. Then we are providing the stop sequence. Once the payload is created, we are passing the payload to create a request. As part of this request, we are telling which foundational model to be used, and we are telling that the bedrock that we are going to invoke the API using the application JSON format. Then we invoke the request using the invoke model, which returns the response. Once the response is received, we are converting that into JSON object so that we can fetch the corresponding element within the JSON to print the response. Note that every foundational model has a different response structure, so refer to the documentation for more details. Now let's add a REST API endpoint to our application by creating a package called web. Under this, add a file called assistantcontroller.java. Now add the get method called askAssistant, which will invoke the ask assistant from the assistant service and provide us the desired response. Now let's start the application. Once the application is ready, open Postman. We are going to ask explain solar system to a 5-year-old in our question, then click send. Our request will be processed by Bedrock API and will return the generated text in response. As you can see, we have received the response, which is understandable to a 5-year-old. One problem with the Synchronous API is that the user has to wait for a very long time without knowing what's happening in the backend. So let's update our code to use asynchronous call. Let's get back to our blog post and scroll down to awsconfig.java. Copy the code for Bedrock Runtime Asynchronous Client and add to the file. Bedrock Runtime Asynchronous Client also accepts two parameters, which is region and AWS credential provider. This is used to take the authorized token and get the access to the AWS resources. Next, go to prompt.java and add another variable for response type. Add the corresponding getter and setter methods. Next, jump on to assistantservice.java and add the instance for Bedrock Runtime Asynchronous Client. Scroll down to Ask Assistant function and add a new variable for response of type string. We'll update the synchronous response to return the value to this response variable and then update the function to return response. Now let's add the if-else condition to control the flow of the program based on the response type. If the response type is synchronous, we will call the synchronous response function. If the response type is asynchronous, we will call the response asynchronous function. Let's copy the code for asynchronous function from the blog post and add it to our assistant service.java file. As you can see, in the asynchronous response function also, we start with creating the payload. In the payload, we are passing the prompt, temperature which tells the relevance of the response, and the max number of tokens required in our response. Once the payload is created, we are going to create a request using the invoke model with response stream request. As part of this, we are going to pass the payload and then the model ID, and we set the content type as application JSON. Once the request is created, the next step is to create a response handler which will listen to the response from the API, and as we receive the chunks of the response, we print it to the output. With this, we are all set. Let's restart the application and go back to Postman. Here we are going to add the new variable for response type and add the value as async. Let's click on the send button and review the results. Okay, something went wrong. Yeah, here I think we have to use response type in lowercase. Let's try it out again. This time we see that the message is coming and it's streaming. As the text is getting generated, we are receiving the response. Thank you for joining us in this exploration of integrating Amazon Bedrock API with Spring Boot. Stay tuned for our next video, where we will discuss about RAG, Retrieval Augmented Generation, vector database, and embeddings to unravel the potential of this powerful fusion of AI and web development technologies. Hi viewers, hope you got the desired insight to get you started. Please like and subscribe to our channel for more insight.